Hi there, welcome to my course. In this lecture you will learn about select statements and modifying clauses. From clauses. The from clauses is easy to understand if you specify only one table. This is the example. This statement returns all the data in all the rows of every column in the customer table. You can, however, specify more than one table in a from clause. Consider the following example. This is the example. This statement forms a virtual table that combines the data from the customer table with the data from the invoice table. Each row in the customer table combines with every row in the invoice table to form the new table. The new virtual table that this combination forms contains the number of rows in the customer table multiplied by the number of rows in the invoice table. If the customer table has 10 rows and the invoice table has 100, the new virtual table has 1000 rows. This operation is called the Cartesian product of the two source tables. The Cartesian product is a type of join. In most applications, the majority of the rows that form as a result of taking the Cartesian product of two tables are meaningless. In the case of the virtual table that forms from the customer and invoice tables, only the rows where the customer ID from the customer table matches the customer ID from the invoice table are of interest. Where clauses. A statement performs an operation only on table rows where a stated condition is true. The syntax of the where clause is as follows. This is the example. The condition in the where clause may be simple or arbitrarily complex. You may join multiple conditions together by using the logical connectives and or and not to create a single condition. The following statements show you some typical examples of where clauses. This is the example. The conditions that these where clauses express are known as predicates. A predicate is an expression that asserts a fact about values. The predicate part dot quantity in stock less than 10, for example, is true if the value for the current row of the column part dot quantity in stock is less than 10. If the assertion is true, it satisfies the condition. An assertion may be true, false, or unknown. The unknown case arises if one or more elements in the assertion are null. The comparison predicates are the most common, but SQL offers several others that greatly increase your capability to distinguish or filter out a desired data item from others in the same column. The following list notes the predicates that give you that filtering capability. This is the list. Comparison predicates. For every row in which the comparison evaluates to a true value, that value satisfies the where clause and the operation executes upon that row. Rows that the comparison evaluates to false are skipped. Consider the following SQL statement. This is the statement. This statement displays all rows from the part table that have a value of less than 10 in the quantity in stock column. Between. Sometimes you want to select a row if the value in a column falls within a specified range. One way to make this selection is by using comparison predicates. For example, you can formulate a where clause to select all the rows in the part table that have a value in the quantity in stock column greater than 10 and less than 100 as follows. This is the figure. This comparison does not include parts with a quantity in stock of exactly 10 or 100, only those values that fall in between these two numbers. To include the endpoints, you can write the statement as follows. This is the statement. Another way of specifying a range that includes the endpoints is to use a between predicate like this. This is the figure. This clause is functionally identical to the preceding example, which uses comparison predicates. This formulation saves some typing and is a little more intuitive than the one that uses two comparison predicates joined by the logical connective AND. Hi there, welcome to my course. In this lecture you will learn about querying multiple tables with subqueries, tuning considerations for statements containing nested queries. How do you tune a nested query? In some cases there is no need because the nested query is about as efficient as it can be. In other cases, nested queries are not particularly efficient. Depending on the characteristics of the DBMS you are using, you may want to record a nested query for higher performance. Many tasks performed by nested queries could also be performed using relational operators. In some cases, using a relational operator yields better performance than a nested query that produces the same result. If performance is an issue in a given application and a nested query seems to be the bottleneck, you might want to try a statement containing a relational operator instead and compare execution times. There are two kinds of subqueries, uncorrelated and correlated. Use the Northwind CS database to take a look at a non-correlated subquery without a set function. This is the example. This query takes data from both the products table and the order details table. It returns the order IDs of all orders that include products that are out of stock. This figure shows the result of the query. The figure shows the execution plan, and this figure shows the client statistics. This was a pretty efficient query. 9070 bytes were transferred from the server, but execution time was only 30 time units. The execution plan shows that an efficient nested loop join was used, which only used 4% of the total time consumed by the query. How would performance change if the where clause condition was inequality rather than equality. Suppose you don't want to wait until a product is out of stock to see if you have a problem. Take a look at figures shown in the slide. This and this the figure, and look the another figure to see how costly a query is that retrieves orders that include products that are almost out of stock. More rows were returned because this query retrieves all the rows the previous one did plus more. The execution plan shows that a merge join was used instead of a nested loop join, and that it consumed proportionally more of the total time. The client statistics show that execution time increased significantly. Could you achieve the same result more efficiently by recording with a relational operator? It does not seem likely that you could do much better than the query with the equality condition. Take a look at an alternative to the query with the inequality condition. This is the example. This figure shows that the same rows are returned. The figure shows that the execution plan is the same as it was for the nested query, and the figure shows that client processing time is up slightly. In this case, it appears that there is no performance penalty involved with using a nested query as opposed to a relational query. This could be due to the fact that the SQL Server Query Optimizer is smart enough to choose the best execution plan regardless of how you code the query. Hi there, welcome to my course. In this lecture, you will learn about building a sample application, designing the user interface. After you have determined the forms, reports, and queries that you must support, you can decide how to arrange things so that the user can quickly specify what she wants and ask the application to deliver it. At this point, you should create some mock-ups of screens and present them to the users for feedback. Present 2 or 3 alternatives, perhaps one with radio but tones and a second with list boxes and push buttons as selection mechanisms for whatever function the user wants. The users feel a greater sense of ownership in the project if they get to choose what it looks like. This helps tremendously in gaining user acceptance. This figure shows a mock-up of the main screen using radio buttons. This figure shows the same screen, but this time implemented with command buttons. After you show the alternatives for the main screen to the users and obtain their feedback, you can proceed to connect the user interface to the database. Connecting the user interface to the database. Design a menu hierarchy to easily take users to the function they wish to perform. This figure shows an example of such a hierarchy for the OLS application. The tools for building forms, reports and queries vary from one DBMS to another. So, I won't go into detail on how to do it here. As an example of what one of the forms on the second level of the hierarchy might look like, this figure shows one possible form for selecting one of the four forms used to view, enter, modify or delete records from the members, authors, research teams and papers tables. Similar forms for reports and queries would also be on the second level. The third level consists of forms for viewing or editing table information. This figure is an example of what such a form might look like for the members table. Of course, you are free to lay out the form any way you wish. Put your company logo on it or follow whatever stylistic conventions are standard in your organization. Adding data with forms. Form-based data entry is easy and less susceptible to data entry errors than a list of command delimited values. The main problem with form-based data entry is that it is non-standard. Each DBMS has its own method of creating forms. This diversity, however, is not a problem for the data entry operator. You can make the form look generally the same from one DBMS to another. Although this is great for the data entry operator, the application developer must return to the bottom of the learning curve every time he changes development tools. Another possible problem with form-based data entry is that some implementations may not permit a full range of validity checks on the data that you enter. The best way to maintain a high level of data integrity in a database is to keep bad data out of the database in the first place. You can prevent the entry of some bad data by applying constraints to the fields on a data entry form. This approach enables you to make sure that the database accepts only data values of the correct type and that fall within a predefined range. Applying such constraints can't prevent all possible errors, but it does cut some of them. Hi there, welcome to my course. In this lecture, you will learn about connecting to a remote database. Native drivers. The simplest form of communication between an application and a database is through a native driver. The figure shows how a native driver, a specific to Oracle 10G connects your application to an Oracle 10G database. This arrangement is not much different from that of a standalone desktop database system. The Oracle 10G native driver is specifically designed to take SQL from the application and translate it into Oracle 10G database commands. When the database returns a result set, the native driver translates it into a standard SQL result set and passes it back to the application. Because native drivers are specifically designed to work with a particular database, they can be highly optimized for that specific situation and thus have very good performance. That specificity which makes possible the native driver's greatest strength is also its biggest weakness. When you build a database system that uses a native driver to connect to one type of database, say Oracle 10G, the connection does not work with any other type of database, such as SQL Server. When you write a database application, the part of the application that communicates with the database is called the application programming interface. ODBC and its major components. An application may need to access data in multiple databases of incomparable types. Incorporating multiple APIs into your code is not a desirable solution. Happily, there is a better way. ODBC, which stands for Open Database Connectivity, is a widely accepted standard method of communicating with most popular database formats. It accomplishes this by adding an extra layer between the application and the database. This figure shows this arrangement. It is unlikely that you would want to connect any realistic application to 5 different data sources as shown in the figure, but with ODBC you could. The application communicates directly with the driver manager. The front end of the driver manager always presents the same API to the application. The back end of the driver manager connects to a driver that is specific to the database on the back end. The driver in turn connects to the database. This arrangement means that the application programmer never has to worry about the details of how to connect to the database on the back end. All you have to do is make your program compatible with the ODBC API and you will be successful. The driver manager makes sure that the correct driver is in place to communicate with the database. File-based drivers. File-based drivers are so named because the driver processes the data source directly. A file-based driver must be capable of processing SQL statements and performing the appropriate operations on the database. No DBMS is involved. File-based drivers apply to desktop databases such as FoxPro as well as to spreadsheet files and other flat files. You can use a file-based driver on a standalone PC or on a network. This figure shows a typical one-tier configuration. In the standalone system, the application, driver manager, driver and data storage are all on the same system. In the network case, the application, driver manager and the driver are on the client, and only the data source is on the server machine. All the intelligence is on the client. Hi there, welcome to my course. In this lecture, you will learn about finding and eliminating bottlenecks using query analyzers. All the major database management systems offer tools to give the DBA or other person responsible for the efficient operation of the database a way of analyzing how well queries on the database are performing. In versions of Microsoft SQL Server prior to SQL Server 2005, the tool for this job was even named Query Analyzer. However, SQL Server 2005 represents a major break from the past in a number of ways. The functions that had been the province of Query Analyzer are incorporated into the new Microsoft SQL Server Management Studio, along with additional functionality useful for tuning query performance. Here is a brief introduction to SQL Server 2005's tuning tools to give you an idea of what such tools look like and what they do. It differs in detail from the operation of similar tools for other database management systems, but the overall functions are the same. The figure shows the main screen of Microsoft SQL Server Management Studio. As you can see, I have connected to a database named Northwind CS. This is a sample SQL Server database provided by Microsoft. If you do not have it already, you can download it from www.msdn.microsoft.com. It contains sample data for a fictitious international trading company. Suppose you are a manager at Northwind and you want to know the customers you have in the USA. You can find out with a simple SQL query. To draft a query in Management Studio, follow these steps. 1. Click the New Query button at the left end of the standard toolbar. This opens an SQL editor pane in the middle of the Management Studio window, as shown in the figure. 2. Type your query into the editor pane, as shown in the figure. The tree at the left shows that the contrary column is a nullable varchar field and that the primary key of the customers table is a customer ID. The country column is not indexed. There are indexes on city, company name, the primary key PK_customers, postal code and region. None of these indexes is of any use for this query. This is an early clue that performance of this query could be improved by tuning. 3. Execute the query by clicking the Execute button. The result of the query shows up in the Results tab, as shown in the figure. 4. Save your query by name from the File menu. The Database Engine Tuning Advisor. The tool SQL Server provides for tuning queries is the Database Engine Tuning Advisor. To use this tool with the sample query created in the previous example, follow these steps. 1. From the Management Studios Tools menu, select Logically Enough Database Engine Tuning Advisor. The Tuning Advisor window showing the General tab appears as shown in the figure. 2. When you are asked to connect to the server you are using, do so. 3. The system has assigned a default session name based on your login and the date and time. Change this session name if you want to. 4. Under Workload, choose File and then click the Browse for a workload file button to the right of the long text box. 5. Find and select the query file that you just created. 6. From the Database for Workload Analysis drop down list, select your database.